Both of you trying this question. This is NEET 1997 question. Any idea how to solve this question, Samaira? Kulsum, how to solve this question? Any idea? And
First we find resistance, which is voltage times 2 by the power, and then I think we use the resistance and the supply voltage. Supply voltage times 2 by the resistance.
okay. So up to some extent you are right. But after that, what? Power is already given and the power has been asked. So why not the answer is 100 watt? Power of a bulb is given and we have been asked the power. In the option we also have 100 watt. Then why not 100
Yes,
watt is answer?
sir, actually the resistance is 200 square by 100, which gives 400 ohms, and the power would be the supply voltage, which is 160 square by 400. Is it?
So what is you are getting?
I'm trying it now. 1 second.
Okay.
Is it D, sir? 64?
How much you are getting?
64.
Correct. I think you are right. You have done the you have applied the right concept. Same would be the method to solve this question. First, what we have to find? We have to find the resistance, right? So the two things of a bulb is given. Suppose we have a bulb. So its rating is given. It's given 100. It's a 100 volt and 200 volt. This is the rating. So now with this rating, what we will do? We'll find resistance. Resistance is, what is this resistance? We know that P is equal to V square by R. So R will be V square upon P, right? So 200 square upon power is 100. Now we have to find the power at the given voltage. So P dash will be equal to V dash square upon R. Resistance of the bulb will remain same. and V dash square will be 160 square divided by R will be 200 square upon 100. So from here we will get 160 into 160 into 100 divided by 4 to 10 to the power 4. So this and this will be cancelled out and we will get 64 watt. So D is the right answer. Have you understood?
Yes, sir.
Samaira, have you got it?
Yes, sir.
All right, moving to the next question. We have one more question based on power. This is NEET 2019 question. So both of you try this. Have you got any answer? Both of you trying this question?
Yes, sir.
So let us see what says. The question says 6 similar bulbs are connected as shown in the figure. It's a NEET 2019 question. We have 6 similar bulbs connected as shown in the figure with a DC source of EMF E. So in the question, EMF of the battery is given, which is E. All right. And zero internal resistance. The ratio of power consumption in the bulbs when all are glowing in the situation when 2 from section A and 1 from section B are glowing. So there are two cases. In first case, it says that all the bulbs are glowing, right? So we can assume, bulbs can be assumed as resistors. So we can assume the combination as like this. We have 6 resistors connected as shown, like this. So bulbs can be considered as resistors. So 6 resistors are connected like this, and the configuration is connected to a battery. And so in this case, what would be the power? So first we will calculate equivalent resistance, R equivalent. So suppose resistance of each bulb is R. So what will be the equivalent resistance? So these all resistors are, first 3 resistors are connected in parallel, another 3 are in parallel, and then the combination is in series. So the equivalent resistance is like this, R by 3 and R by 3, like this, R by 3 and R by 3 in series. Both of you understood this, how we got R by 3 and R by 3? Yes, see, these resistors are in parallel, so their equivalent resistance is R by 3, and these resistors are in parallel, so their equivalent is R by 3. Now both of these are in series, so R equivalent will be equal to 2R by 3, right? Both of you understood this, how we got 2R by 3?
Yes, sir.
Now it says in second case, according to this question, in the second case, in this situation, second case, what happens? 2 from section A, 2 from section A and 1 from section B are glowing. Now other bulbs are removed and situation is like this. We have 2 resistors in parallel and it is in series with one of the resistors. So what will be equivalent resistance here? It will be, this has R by 2, this equivalent is R by 2 and this is R. So this will be R plus R by 2. It means 3R by 2, right? 3R by 2. So now we will calculate power. First, for first case, P1 will be equal to V square by R. It means V square by R means E square by 2R by 3. And in second case, power will be, for second case, power will be E square divided by 3R by 2. 3R by 2. So we will take the ratio P1 by P2. So P1 by P2 will be equal to reverse of resistance. So 3R by 2 divided by 2R by 3. So I think we will get 9R by 4. Understood it? So basically power will be inversely proportional to resistance. Here EMF is constant. So we have to find the resistance, ratio of resistance in both the cases. Understood? Any doubt, please ask. So the correct answer is B. All of you got it? Or we got 9:4?
Yes, sir.
All right. So this is how we should proceed for the questions based on power. Now we will do a formula for combination of cells. So let us do a theory for combination of cells. As we have combination of resistors, in the similar way, we also have combination of cells. So let us discuss the theory based on combination of cells. The next theory is combination of cells. Combination of cells. So what is it? There are two types of combination of cells. One is series combination, which is very easy. We all know the formula for series combination. What is that? Series combination. What is that? Suppose we have two cells like this. Having EMF E1 and their resistance is R1. EMF is E2, resistance is R2. So for series combination, what happens? E equivalent is given by E1 plus E2. And what is R equivalent? Equivalent resistance is R1 plus R2. So this is the formula for equivalent EMF of series combination. For n number of cells, we will add more number of cells. If there are 3 cells, then it will be E1 plus E2 plus E3. If there are a number of cells, then it will be E1 plus E2 plus E3 dot dot En. Same way with the resistance. Now the main question arises when we have combination of cells in parallel. Series, we already know the concept, we can solve the questions. Parallel formula is little difficult to remember. So we will learn what is the formula for parallel combination. Suppose we have two cells having EMF E1 and R2, E1 and E2, and internal resistance R1 and R2, and connected in parallel. Suppose this EMF is E1, internal resistance is R1, EMF is E2, and internal resistance is R. So for such cases, equivalent EMF is given by E1 by R1 plus E2 by R2 divided by 1 by R1 plus 1 by R. This is the simplest formula which we can remember. Directly you can write E equivalent is E1 by R1 plus E2 by R2 divided by 1 by R1 plus 1 by R2. This is the simplest way. For n number of cell, like if there are 3 cell, you can continue like E1 1R1 plus E2 by R2 plus E3 by R2. So you can continue it like this. If there are n number of cells, you can continue the formula. So this is the simplest formula we can remember for parallel combination of cells. There are number of formula which are difficult to remember. This one I thought easiest to remember. E equivalent is E1 by R1 plus E2 by R2 divided by 1 by R1 plus 1 by R2. So this is the formula for equivalent EMF for parallel combination of cell. So let us do one question based on this. Then we will do some other questions based on this concept and other concepts. So let us first do question based on parallel combination of cells. So all of you try this question number 58. It is NEET 2005 question. So all of you try this. So what we have to do is we have to, according to the question, we have to find the equivalent EMF, since we have to find the voltage of the reading of the voltmeter, and from the configuration we can see that the cells are in parallel. So we can find the equivalent EMF by using the formula E1 by R1 plus E2 by R2 divided by 1 by R1 plus 1 by. So all of you understood this, how the cells are in parallel? Any doubt? All of you can identify, right? It is in parallel, right? So all of you can identify it. All of you can get it. It is in parallel. All right. So now put the formula and we will get the values. So let us see. Here we have E1 like 18 volt and internal resistance is 2 plus E2 is like 12 volt by 1 divided by 1 by R1 means 1 by 2 plus 1 by 1. So we will get it as 9 plus 12 divided by 3 by 2, right? So we can get 21 by 3 into 2, then 14 volt. So the correct answer is D. Understood? How to apply parallel combination of cells, and we can solve the question. All of you got this? Any doubt, please ask. Okay.
Yes, sir.
Moving to the next theory, that is very easy theory. That is Wheatstone bridge. We already know that. What is Wheatstone bridge? Very important. Most of the time questions are asked based on Wheatstone bridge. So we already have that concept. What is Wheatstone bridge? Wheatstone bridge. What it is? We know that if there are 4 resistance connected in such a way, like we have, suppose we have a resistance R1, another resistance is R2, we have another resistance R3, and another resistance is like this. Suppose we have a resistance R1, R2, R3 and R4. So, and it is connected like this with some external EMF, and suppose there is a galvanometer connected between 2 points G. Suppose we have a point A, B, C, D. So if, what is the balance condition? We already know. Balance condition of Wheatstone, what is that? If we will not go to the ratio technique, ratio technique is very difficult. Sometimes we write R1 by R2, sometimes we may write R2 by R1. So there is a confusion. So there we always write wrong formulas. So it's better we will always remember that for balancing a Wheatstone bridge, we will apply a trick, that is the product of these resistors will be equal to product of these resistors. This is easy to remember. We generally forget ratio, what is R1 by R2 and should we take R1 by R2 or R1 by R3? So that confusion always remains. So you will not be confused if you remember this way. Balance condition is like this. If R1 into R4 is equal to R2 into R3. It means multiply of opposite resistors. If those are equal, then Wheatstone bridge will be balanced, and in that case, current through galvanometer is 0. And in that case, current through the galvanometer is 0. And if there is a resistor in this branch, suppose we have resistor R5 in the branch, so we can remove that, right? We can remove that. So in balance condition, what we can do? We can remove the middle resistor, and we can have like this. Only 4 resistors are there. the structure become like this, and you can easily find the equivalent resistance. Suppose this is R1, R2, R3, R4. So you can easily find. Suppose this one is R4, R3. So now you can easily find the equivalent resistance. What you have to do? You have to do series combination of this and series combination of this, and both are in parallel. So you can easily find. So this is the concept of Wheatstone bridge, and how to remember this. So based on that, do anyone having doubt in this? Very easy concept. I think no one should have a doubt on this. We will do question based on Wheatstone bridge. Anyone having doubt on Wheatstone bridge? Please ask. All right. So we will do some question based on Wheatstone bridge. Let us see this question. All of you try this. This is NEET 2005 question. It is based on Wheatstone bridge concept. So all of you attempt this question. All of you trying this question?
Yes, sir.
Am I better audible today? Okay. So let us solve this question. Very easy question. I worried why any of you have not solved the question. It is based on Wheatstone bridge only. So what we have to do, we have to apply the concept of Wheatstone bridge. So for that, what we have to see the multiplication of opposite resistors. So Kulsum got D. To see it is 12, and again you have to see the opposite resistors. These two resistors. This is also 12, right? So it is balanced with stone bridge. It is balanced with stone bridge. for that we can remove 4 ohm resistor. So the equivalent circuit will be like this. This is 2 ohm, this is 3 ohm, this is 6 ohm, and this is 4 ohm. Middle resistor will be removed, and now it is connected to a battery of EMF V. So we can easily find equivalent resistance. What is that? If you see here, how to find the equivalent resistance? First, find equivalent resistance of these two resistors. These are in series, so it will lead to 6 ohm, and these also in series. Sorry, the point is there is a mistake in the connection. This point is connected there. So this point is not connected here. This point is connected to this according to the question. So now we will see the other two resistors. These are also in series. So it will be 9 ohm. Now these are in parallel. So equivalent resistance will be 6 into 9 by 9 plus 6, right? So 54 upon 15. So 18 upon 5. So it is the equivalent resistance, right? Now what will be the current? Current will be equivalent voltage upon resistance. So 18 upon 5. So it will be 5V upon 80. So D is the correct answer. I think Kulsum, you were right. D is the correct answer. So this is the way how to solve question based on Whetstone bridge. Anyone having any doubt, please ask. All right. Now moving to the next concept that is very important, which is KVL. So Krichov laws. In this concept, we are going to do Krichov laws. Sorry, there is Krichov is a tough spelling. So I will try to write as much as correct I can. Kirchhoff's law. So there are two Kirchhoff's laws. One is known as Kirchhoff voltage, first is Kirchhoff junction law. Kirchhoff's junction law. Or it is also known as Kirchhoff current law or KCL or Kirchhoff first law also. It is also known as Kirchhoff first law. Krichhoff's first law. Or Kirchhoff junction rule, it is also known as Kirchhoff junction rule, Kirchhoff first law, or Kirchhoff current law, all are same. So what is it? According to this, sum of current, algebraic sum of currents, according to this algebraic sum of currents meeting at a point is 0. Algebraic sum of currents meeting at a point or junction is 0. What does it mean? Suppose we have a junction, so no need to go in theory basically, and it is basically based on conservation of charge. It is basically based on conservation of charge. Conservation of charge. It is based on conservation of charge. So according to this law, if you see in the diagram like this, we can understand it like this. Suppose we have a junction. What is junction means? Junction means whenever two things are crossing at a point, it is called junction. You may have heard about railway junction, right? Railway station and railway junction. So there is a difference between railway station and railway junction, which I think you all know. Junction is the point from where junction is the I can say from where trains moves in all direction, right? But in stations there are monodirectional currents are coming, but at junction you have trains are coming from different direction. So same is the case here. Suppose this is a junction, so current will come from all direction, like I1, I2, I3 and I4. So what, according to KCL, Krichhoff current law, or Krichhoff junction rule, what it says, the algebraic sum. So generally what we will do, incoming current will be taken as positive, incoming current, and outgoing current will be taken as negative. So according to Krichhoff junction law or Krichhoff current law, what it says, according to this, the algebraic sum of current meeting at a junction is 0. So here what is junction? Here junction is this point. This point is basically junction. So incoming current will be taken as positive. So incoming currents are I1 and I3. These are incoming currents, and outgoing currents are I2 and I4. So this should be equal to 0. It means number of currents meeting at a point or coming at a point will be equal to number of current going outside the point. So this is basically Krichhoff junction law, Krichhoff junction rule, or Krichhoff current law. All of you understood this? Anyone having any doubt, please ask. Very easy concept. All you have to do is you have to equate number of incoming current with the number of outgoing currents. That's all. Nothing more than that. So anyone having any doubt, please ask. All of you understood this? All right. So based on this Krichov junction law, we will do one question. Not much questions are asked based on junction law. Basically, we will have more and more question on based on Krichov voltage law. But I am giving you one question which is based on Krichov current law. Suppose we have, I will do one example. Example based on Krichov current law. So suppose I have a branch like this and currents are coming from different direction like this, like this, like this. So suppose from here we have 8 ampere current is coming, and suppose from here 2 ampere current is coming. Suppose here we have 2 ampere current, and suppose here we have 4 ampere current. Suppose this value is I, so we have to find out the value of I. All of you understood this? Suppose we have branches of wires like this, 8 ampere current. 8 ampere current is incoming from this direction, and 2 ampere current is there, and in this branch 2 ampere current is there, and this is 4 ampere current. So we have to find this value. What is the value of I? So all of you try this and get me the value. All of you trying this question? So let us see how to solve this question. See, we have two currents. See here, we have two currents. 2 ampere current is coming from here, 8 ampere is coming from here. So net current which will be going towards right will be 10 ampere. Now 10 ampere is coming this way. Now if you see here, 4 and 2 are going. It means here 6 ampere current will be going from this side. So now for this junction, what you can write? You can write 10. 10 is incoming. 10 should be equal to I plus 6. I and 6 are outgoing. So from here you can find the value of I. 10 minus 6, it should be 4 ampere. All of you understood it? How we are getting 4 ampere? Alright, so this was Krichov junction law and how to solve the question based on junction law. Then the most important is Krichov voltage law. So let us do that. Krichov voltage law, KVL. What is KVL? The second law, which is Krichov voltage law. If you command down Krichov voltage law, you can solve any kind of electrical circuits very easily. Any kind of electrical circuit can be solved using Krichov voltage law. So Krichov voltage law. Generally we write it as KVL, or it is also known as Krichov second law, or Krichov voltage rule also it is known as. So it is Krichhoff's voltage law or Krichhoff second law. It is basically based on conservation of energy. It is basically based on conservation of energy. Based on conservation of energy. According to this law, the algebraic sum of potential differences in a loop, the algebraic sum of potential differences in a loop. Potential differences we can write also taken in order. We must follow an order taken in order. Order means in a sequence. So the algebraic sum of potential difference in a loop is 0. So we will understand it by example, or we can say it says sigma v should be equal to 0. And in first case, sigma I was 0. Sum of currents meeting at a point is 0. That is why the name Krichhoff current law. And here we are discussing about voltage. That is why it is known as Krichhoff voltage law. So we will understand it first through an example. Then we will do questions. So according to and it is very important to know how to apply Krichhoff voltage law. That is the most important thing. So I will assume a arbitrary circuit, electrical circuit, and I will show you how to apply Krichov voltage law on that circuit, and then we can do the questions based on the concepts. So let us assume that I have a circuit like this. Suppose I have a circuit like this in which I have an EMF E1, resistance R1, then I have a cell of some EMF, then resistance, then I have another cell, then resistance, then suppose I have another cell like this. Suppose this resistance is R1, EMF is E1, and this is EMF is E2, this resistance is R2, and this EMF is 3, and this resistance is R3. So we have to find, using Krichov voltage law, we will find an equation, and then we will know how to apply this concept to the questions. That is the most important thing. So first we will assume now let us understand it very clearly how to apply the Krichov voltage law. The main thing is how to apply it, so that we are going to learn. So to apply the Krichov voltage law, what we do is, basically this is also known as Krichov loop rule also, like Krichov loop rule. So it is always applies across a loop. So first we have to identify a loop so that we can apply, to find the Krichov junction law, you must have to identify a junction. In the similar way, to apply the Krichov voltage law, first you have to find a loop, because since Krichov voltage law can only be applied across a loop also. So suppose we have a loop, this one is a loop, closed circuit. Now what we will do is, we will assign signs, like signs means like generally what we do, we will assign some sign, like this is minus, negative terminal of battery will be taken as minus, and positive terminal of the battery will be taken as plus. So this will be minus and plus, and what we will take a sign convention is, we will take positive when moving from negative to positive, and we will take negative when moving from positive to negative. So this will be our concept. When we are moving from positive to negative, we will take negative, means final minus initial we are going to discuss. So simply you can remember, if you are moving from negative to positive, then we will take the sign as positive, and when we are moving positive to negative, then we will take the sign as negative. So to find that, first we will assume a current in the circuit. Suppose current in the circuit is I. Now we know that current always flows from high potential to low potential, that we will all know. So the sign of resistors will be decided accordingly. Like current is moving like this here, so we will take this as positive and this as negative, since current is moving from high potential to low potential. Similarly, current is moving in a circuit like this, so here we will assume positive, here negative, here we will assume positive, here negative. So this is the our the steps to apply KVL. First we have to uh, assign the signs, that is sign which is positive or negative, then and only then we can apply the Krichov voltage law. And also we have to assume a current in the circuit. So here we have assumed current I in the circuit. Now we'll start from here. So you see here what we are doing. Now you can see we are moving from, if you can see here, we are moving from here to here, right? So we are moving from positive to negative. So what we will do, we will take potential difference, which is IR1, and it should be negative since we are moving from positive to negative. Now see this cell. Now we will move to the cell. See this cell. Here we are moving from negative to positive. First we are coming across negative, then positive. So what we will do? We will take positive sign E1. Similarly, you can see here you are moving from negative to positive. So we will take positive E2. Again, we are moving from positive to negative. So we will take minus sign IR2. Then we are moving from negative to positive. So we will take positive E3. Then we are moving from positive to negative. So we will take negative IR3. Then we are moving from negative to positive. Suppose EMF is E4. So we will take plus E4, and that should be equal to 0. All of you understood this, how I have written this expression by applying Krichov voltage law? That is very crucial. We have to apply Krichov voltage law every time when we have complex electrical circuit. So anyone having any doubt, please ask at this stage so that you can acquire the further concept, since we are going to do number of questions based on Krichov voltage law. And this is the most important
No,
part
sir.
of this
No doubt.
chapter. So anyone having any doubt, please ask.
No doubt, sir.
All right. So based on that, we will do some question based on Kirchhoff law so that we can understood it clearly, and then we will move further. So let us see some questions based on Kirchhoff law. So Kirchhoff voltage law is basically based on conservation of energy. Since energy and voltage are related, right? We all know that energy and voltage are related. So sometimes we have been asked that Kirchhoff current law is based on. So Kirchhoff current law is based on conservation of charge, and Kirchhoff voltage law is based on conservation of energy. So let us do some questions in which we can directly apply Kirchhoff voltage law. Generally, NEET, not much questions are asked based on Kirchhoff voltage law, but in JEE it is very important. But we should have basic idea of Kirchhoff voltage law. Without that, we cannot solve circuits. So first we will do question based on Kirchhoff laws. Then we can do some other question based on series and parallel combination of cells, which we have already discussed. So let us see this. First, see this question number 90. All of you see this question number 90. This is NEET 2010 question. So very easy, solve it. So according to the Samaira, the correct answer is D. Anyone else? So let us see what has been asked in the question. What it says, we have to identify the correct statements, right? So what is the first statement? Krichov junction law follows from conservation of charge. Yes, this is we have already discussed. Krichov junction law is based on conservation of charge. Now what is the statement B says? Krichov loop law follows conservation of energy. Yes, correct. Krichov loop law or Krichov voltage law is based on conservation of energy. So both are correct. So correct option is D. So Samara, you were right. The correct option is D. Anyone having any doubt? Very easy question. Please ask. Anyone having any doubt in this? This is directly based on this statement. So I think no one should have doubt based on this. Now solve this question number 89. Here we have to apply all the both the laws. So all of you solve this question number 89. All of you trying this? So let us see. According to the question, it says in this circuit shown in the figure, if the potential at point A is taken to be 0. So it says that take VA equal to 0 then potential and B. Then we have to find what is the potential at B. So in the question it is given that if potential at A is 0, then what is the potential at point B? All right. So we have to find potential at point B. So let us see how to solve this question using. So first I will give you idea how to approach such questions. Here you see, if you can see here 2 ampere current is flowing. So 2 ampere current will flow like this. But here you can see 1 ampere current is going in this direction. It means 1 ampere current will be here. Since at junction D, 2 ampere current was incoming and outgoing current from R1 is 1 ampere. It means current from this resistor should be 1 ampere, right? So it's 1 ampere. Now again here we have 2 amperes. So here we can have two loops. If you see, we have two loops. Suppose this loop is L1 and this loop is L2. And our aim is to find the potential at point B. We have to find the potential of point B. So also in the question it is given that VA is 0. VA is 0. So now we can apply Krichov law. So for L1, we will apply for L1, we will apply the KVL for L1. So what we can write? We will start from the cell. So we can write 2 minus 1 into 2 1 into 2 minus 2, and here this resistance we don't know, right? In the question this resistance has not been given, and R1 and R2 is also not given, right? R1 and R2 also has not been given. So from here you can write 2 minus 2 minus 1 into 2 minus 2 into R, that should be equal to 0. So from here you can calculate R. 2R will be equal to 2 into 1 minus 2 into R, that should be equal to 0. So from here you are getting value of R as 0. Is it possible? Let us see once again, check it. We have 2 ampere current, 1 ampere is splitting. So 2 minus 1 into 2 and again 2 into R. Okay, we cannot write 2 into R. Here there is a mistake. You cannot write 2 into R. We don't know the potential of, so it's better, since we don't know the resistance R, so it's better to write this potential difference Potential difference across the resistors we don't know. So for that, what you have to write is, see here, you can write is, here you can write potential difference also as Vc minus Vb, right? Since we don't know, Vc minus Vb is equal to I into R, right? So it's better, since resistance we don't know, so here it's always better, equivalently you can write it like this. Instead of writing 2 into R, since we don't know the resistance, we can write here like Vc minus Vb, right? So from here you will get Vc minus Vb. If you see from here, you can get Vc minus Vb will be equal to 0 volt, right? Vc minus Vb equal to 0 volt. It means you can say that Vc will be equal to Vb. Potential across C will be equal to potential across B. Now our job is to find potential across C. If we can find potential across C, we will easily get potential across B. So to find the potential across C, we have to approach this loop. You have to go in the loop L2. So now we will apply KVL in loop L2. So how to apply KVL in loop L2? So from the what we have to do is, we can also do it like this. If you see the branch below, if you see here, you can write Vc minus Va, that is equal to 1 volt, since battery is given. So you can directly write Vc minus Va equal to 1 volt. And in the question, if you see, in the question Va is 0, right? The question Va is 0. So from here you can directly write, Vc minus 0 equal to 1 volt. So from here what you will get? Vc will be equal to 1 volt, right? Vc will be equal to 1 volt. So if you got Vc, now you can find Vb. We have seen here that Vc equal to Vb, and we got Vc equal to 1 volt. Therefore, Vb will also equal to 1 volt. So correct option is A. All of you understood this? Anyone having any doubt, please ask. Anyone having any doubt in this? This is NEET 2011 question and very basic question based on Krichov laws. So anyone having any doubt, please ask. All of you understood how we got Vc equal to Vb and how we calculated Vc minus Va equal to 1 volt, and then we got Vc equal to 1 volt, and therefore we calculated Vb is equal to 1 volt. So this is how we should proceed to apply Krichov voltage law. And if you know the Krichov voltage law, you can easily solve any kind of circuit. So let us see one more very basic circuit. I will give you some question in assignments also to solve questions based on Krichov law. So all of you quickly do the question number 92 and 93. Very easy statement based question. So all of you do question number 92 and 93 very quickly. What it says, see question number 92. What it says,